These notes cover Chapter 1, Sections 1 and 2. Computer programming in any language is about solving problems. We wish to automate solutions to tasks and be able to use them over and over again. Therefore, the style of programming we will use this semester promotes reusability, extendability, and readability. Let's get started. How do we communicate with the computer? Well, we use programming languages. Modern programming languages are designed for people to write logical solutions that are easily read and understood by other humans. The computer does not understand Python. It must be translated into machine code for the computer to run the instructions. How do we get computers to perform complicated tasks? Well, we break these tasks down into a sequence of instructions. The complication is actually for the humans who write the code. The computer will have no trouble once it's been translated into machine code to run our instructions. Why use Python? Python is a powerful, easy to use programming language. Now, make no mistake, we are going to have to practice and study and scratch our heads a little bit with Python, but that's true of any programming language. It's a challenging task, but one I think you will enjoy. How did the language Python get its name? Well, actually, it's kind of funny. It's named for the British comedy group Monty Python. Really? If you're not familiar with Monty Python, you should Google it. Check it out. Pretty funny humor. The book uses the editor IDLE to create programs. How did IDLE get its name? Well, technically they say it stands for Integrated Development Environment. Now notice that little extra L in there. I think it's really named for Eric Idle, one of the original Monty Python troupe members. What is an interpreted language? Interpreted languages translate our high-level language, like Python, one statement at a time into machine language and then run it immediately. So it's very interactive with the code you've written. What are the meanings of the terms programmer and user? First off, the programmer is responsible for writing the code. The person who solves problems and writes solutions to those problems in the computer language. The user is any person who runs a program or uses that software that's been written by a programmer. You could compare this to a mechanic for the car is like a programmer for a car, and all of us who drive cars are like users of cars. We're going to become the mechanics of software development. What is the meaning of the term code? Python statements that the programmer writes are called code, or programs, or instructions, or software. All of those words are pretty interchangeable, but the finished product is usually referred to as a program, an application, or software. Are there certain characteristics that all programs have in common? Absolutely. And a really good starting point is to consider our programs in terms of input, processing, and output. This outline will provide a guide for us coming up with our solutions to the problems at hand. You've frequently heard the terms hardware and software. Let's be sure we understand the distinction. Hardware are the physical components of the computer. Software are the programs. or the instructions that the programmers write to get the computer to do work for us. You will be all about software this semester. How are problems solved with a program? Well, in step-by-step procedures devised to process given data and produce requested output. That's a pretty fancy answer to that question. For us, we'll be breaking it down into structuring our program instructions in terms of input, processing, and output. What is zero-based numbering system? Numbering begins with 0 instead of 1. This is the way programmers work. When we count from 0. So for instance, the word hello, when it's stored inside the computer, is 5 characters, but we number them 0 through 4. So the H is character 0. The O is character 4. But the size is 5 characters. Are there any prerequisites to learning Python? Well, you do need to be familiar with how folders and files are managed so that you can store your programs in an organized fashion. It also helps to have an eagerness to learn and patience. There will be some real challenges ahead, but the more you practice, the better you will get. Also, there's something really cool about being able to tell the computer what you want it to do and have it do it. What is an example of a program developed in this textbook? This figure shows a possible output for a program in Chapter 3. Now we're sort of getting ahead of ourselves here, but since your book brought it up, we'll talk about it. The question is, can we get the computer to tell us the names of different presidents if we have all the names of the presidents in a list on a file in the computer? So this program from Chapter 3, number 10, opens a file, and inside that file it has all of the presidents of the United States up until 2013. And the program will ask the user to type in a first name, look through the list, and find all matching first names of the presidents in that file. For those of you that have done programming before, you could probably look at this and figure out which line of code is doing what. For those of you who have no programming background, don't be intimidated. Believe it or not, in a few short weeks, you will be writing programs such as this. But what's really cool about this program is that it's only about 10 lines of code that allow us to open a file, search for something in that file, report on if we find it, and then close the file. So here are some of the conventions from the textbook. These are pretty standard. If you see key 1 plus key 2, like Control plus print screen, it means to hold down key 1 and then press key 2. Control C places selected material into the clipboard. So this is popular, Control plus C, and that will copy material to the clipboard. Control plus V will paste the material from the clipboard. When the textbook uses key 1 / key 2, it means release key 1 and then press key 2. So one of the shortcuts to open a file is Alt and then F, and that will open a file menu on the menu bar. How can the programs for the examples in this textbook be obtained? The information is in the preface, and although the program examples are available through the Pearson website, I will be posting them at our class website as we study each chapter week by week. Now here's another note. There is premium content available to you, and you can get to this by registering at the companion website. The instructions for this and the code you will need for the premium content is stamped on the inside page of the front cover of your textbook. The code is in a scratch-off bar. This does include the textbook provided videos, but I will be posting them each week as we get to those topics. Where will new programs be saved? You really should create a special folder on your computer to hold your programs. You will be asked to submit digital copies of your programs for grading, and it's probably good to organize yourself in a week by week or chapter by chapter fashion, so it's easy for you to find the files you're looking for. Where can I research questions I have about Python? There's lots of documentation at the python.org website where you downloaded the software from. Also, if you find a good resource, please post it and share it online in the forum. Here is our program development life cycle. This is such an important picture. It is an overview or an abstract view of how we use a computer and how a program works. It will also guide us in developing our programs. Here are the 5 general phases for solving a problem through software development. No matter how large or small the problem, in industry, these are the 5 steps that are taken. We need to analyze, and this takes time. We have to think about that problem completely. Design a program solution. In the analyze and design phase, this is before we do any coding. And after these 2 phases, you should be able to code in any programming language you like. So they're not specific to Python. They're general purpose programming tools. We code by translating the algorithm from the design into a programming language. This semester we're using Python. Then we need to test and correct any problems we have. This is an important phase of software development. And everybody makes mistakes. Frequently, these are referred to as bugs. You need to locate and remove any errors or bugs in the program, retest to make sure we didn't break any other part of the program. And finally, it's important that we provide documentation. We need to organize all the materials that describes the program, provide information to other programmers, users of the program, so that they can properly understand and use our software. Happy coding!